Never. Okay. So, welcome to session 4. Session 4's topic is inference. This is the last general content session that we're going to have. Session 5, I believe, is about multiple choice strategy. And session 6 is about free response strategy. Okay, so this is the last time that we're specifically targeting certain content. And then the next two are going to focus on just sort of exam specific stuff. By multiple choice strategy, I don't mean, don't spend too much time on one question, come back to the ones that you couldn't figure out. I don't mean that kind of strategy. I do mean statistics, specific strategies, and we're going to do a lot of practice and stuff. And then that last session is on a Saturday. Don't forget that. If you look at that calendar, next week is normal. Miss Moda is Tuesday and I'm Thursday. But then it's that Saturday that's session 6. So if you're going for all 6 sessions for your 4th quarter automatic A, one of those is going to involve a Saturday. Right now on the schedule, I believe it says 9 to 1. We are probably going to change that to 9 to 12. We thought 4 hours was an awfully long amount of time. So that's probably going to be cut to 3 hours. Okay? Nick, question? Your friend. Yes. Okay.
If you go to home?
Danielle, what's the exact date? I can't remember. 5/3 or 5/4, whatever that Saturday is. Yeah. Okay, guys, too much talking. Way too much talking. Please. Thank you so much. Not really. There we go. Okay. So, today we are going to begin by talking about how to recognize which test or which interval you're supposed to do. That's some feedback that I've gotten from you guys is, man, I really just need practice knowing which procedure to do. If I'm on the right track and I've got the right procedure, I can get 4 points on an FRQ. But if I have a hard time picking which procedure to do. So we're going to talk about that first. Then I'm briefly going to review Inference Toolbox with you. I say briefly because we were very, 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 very good at this, and I don't want to spend a ton of time on something that we're good at. However, some things have slipped, and we started accepting hypotheses when we should be failing to reject said hypotheses, and we started doing some other stuff too. So we're going to kind of fix some of that a little bit. Then I'm going to review type 1, type 2 error, that kind of thing. Today I want to make sure we spend enough time doing multiple choice because I think inference should be really strong for us in the free response section, but it might be a little weak for us in the multiple choice section. So I want to make sure we really get to spend a good amount of time practicing multiple choice. So we're going to try to actually stick to this schedule for once. Any questions before I start? Cool. I think this is probably a record attendance day. Does it feel like it? It feels like it to me. Okay. There really is, guys, there's some room down here if y'all want to sit and be closer. There's some space if you want to sit up here. Also, if you're sitting back there, obviously it's fine on the counters. Just don't mess with any of the files or anything like that because we're working really hard to get all your old tests and stuff organized. And if that gets knocked down, I'm going to quit my job. So. Okay. Okay. Miguel, I've missed having you at these sessions. I'm so glad you're here today.
That's right. I feel like I've heard this before.
So recognizing which test or which interval to use. First of all, you have to know what your options are. So let's run through all of the tests that we have learned. Oh my goodness, it is a lot. It's a whole slide worth. I guess somebody name one. Let's see if you can get inside my head and name them in the same order that I have on here. Benin?
One sample Z.
Good. That's the first one I have. One sample Z test. Leandra?
One sample T test.
Good. Man, you guys are good. One sample T test. Beautiful. So many good choices. Jesus.
Two sample Z test.
You're right, but I'm going to put something else up first. Jessica? Yeah. One proportion Z test. Then Jesus said 2 sample Z test. Francis? Brilliant. 2 sample T test. Jail?
2 proportion Z.
Good. 2 proportion Z test. Then what? Miguel says chi-square, and Ray added on goodness of fit. That's teamwork. Chi-square test for goodness of fit. Cedric. Chi-square independence. Good.
Homogeneity.
And chi-square homogeneity. I think I put them on the same line because they're really the same test,
then
right?
regression.
And then Nick. Something.
Linear regression.
Yeah, linear regression t-test. Those are your options.
And then
And you can replace any test with the word interval. So double these. That's how many options you have. Okay, don't replace any of them with interval. You cannot do a chi-square interval. You're right. Michelle?
Isn't there, like, when we run over the FRQ, say the 2 samples Z test and T test can go into match?
Okay, good point. So Michelle said, because we were going, at least my class was going over their FRQs today. Not only do we have a 1 sample t-test, we can also do a paired t-test, which would be a 1 sample t-test where we analyze paired differences. Yes? Okay.
Wait.
Yes. Just wait. The paired t-test is the same mechanically as the 1 sample t-test because I just have 1 list that I'm analyzing and it's a list of differences. Now you probably wouldn't be given that list of differences. You'd be given the 2 lists and you'd have to subtract them and then analyze those differences that you created, that you generated. Yeah? These are our options. But look, we were able to just crank those out like nothing. You know this, okay? Can someone raise their hand and tell me how you can recognize if a problem is about proportions? Cedric.
Population standard deviation.
nope.
Hang on. Don't laugh. Cedric was just anticipating what my next question was going to be. I'm going to come back to you on that, Cedric. So how do you know if it's about proportions? Yeah.
If they give you like percentages. Right?
Okay. If you're given some percentages, it's probably a proportions problem. George, do you want to add to that?
A number out of numbers?
Yeah, my data looks like 5 out of 54. Yeah? Okay? It also might literally have the word proportion in it. Yes? Okay. If the problem is about means, I don't know, what does it look like? Grace? They might say the word average. They've either got to give you data or give you the mean and standard deviation. Yeah? So you might see some standard deviations. Okay. Hey, Cedric. What's the difference between a 1 sample Z test and a 1 sample T test? Or between a 2 sample Z test and a 2 sample T test? Cedric?
Population standard deviation.
Yes. If I have the population standard deviation, which one is it? Z. And if it's going to be T, that means I'm using what? S, the sample standard deviation. This is great, guys.
Yes.
Either because you're given S, or because you're given the data and you get the sample standard deviation from the data. Yes? Okay. Are we feeling comfortable right now?
Very cozy.
Okay, I don't know what you guys just said. All right, so I'm going to go through about 1, 2, 3, 4, 5, 6, 7 or so scenarios and have us pick out what kind of procedure it would be. Okay? Actually, before we do that, chi-square. How can you recognize chi-square?
Good one.
Mylan?
Doesn't one of them have charts?
Yeah, we'll probably have a table of data, right? Specifically with these, it'll be a 2-way table. Some of you tried to do chi-square on the practice exam. That was wrong, okay? The reason that was wrong, and I wish I had the document camera up, the numbers in the table on question 4 were decimals. You can't have decimals in chi-square. Chi-square is all about counts. Yes? I can't have 22.6 people falling in that category. That makes no sense. If there are decimals, it's not chi-square. Yeah? Chi-square is about categorical data. So yeah, we've got a two-way table. We've got something split into categories, something like that. Yes? Okay. And then linear regression, if you look at the data and make a scatter plot out of it, it's probably a linear regression test. Yes? Okay. Let's look at the first scenario. I don't want us shouting it out because I want everybody to have time to process. Okay? Okay. There's a lot of processing going on. Okay. Here are the degree of reading power scores for an SRS of 44 third grade students from a suburban school district. Here's the data. We're not going to do the problem. We're just going to identify the procedure. The researcher believes that the mean score of all third graders in this district is higher than the national mean, which is 32. Do these data lend support to his belief? Shh. Okay. I want you to take maybe a good 15 seconds and think. I want to know what the test is, and let's go ahead and do the ha and the ha.
What's that?
Jazz just trying to make my blood pressure go up. I don't think that 15 seconds isn't, well, maybe it is. Ooh, I got it. 15 seconds. Darius, what procedure, I can't hear him. What procedure would you use, Ben? Very good. One sample t-test. How do you know it's a means problem? Miguel?
The researcher believes that the mean score.
Oh, okay. I've also got a big old list of data. Yes? Okay.
National mean.
Yeah, the word mean is on here in several places. Why is it T and not Z? Jael?
Have data.
I have data and I don't have a population standard deviation. Good. Okay, can somebody tell me what the null hypothesis would be, Leandra? Good. Mu equals 32. Yes. And the alternative? Miguel.
He is greater than 32.
Okay. Okay, Francis.
Never mind.
Okay. If I were to do step 1, I would say I want to, what? Test a claim about, I'm not comparing, it's just about mu, the true mean score. This is creepy. Yes, that was beautiful. I very clearly heard the word true, and I very clearly heard the word all. We are, well, for some of you, that makes it clear that we are talking about a population here, not a sample. Yeah? Yeah, Francis.
What is our population here? All third graders?
All third graders in this district. Because we're trying to prove that the third graders in this district have a higher average DRP score than the national average, which is 32. Yep, good question. Ready for another example? Okay, we're going to be quiet now. Whoa, the medical director of a large company wants to see how his young executive's blood pressure stacks up against the national average. The mean systolic blood pressure of males 35 to 44 years of age is 128, and the standard deviation is 15. The director examines the records of 72 male executives in this age group, and he finds that their mean systolic blood pressure is X bar equals 129.93. Is this significant evidence that the mean blood pressure of the company's young executives is different than the national average? We're thinking. Okay. What do we think? What do we think? What do we think? Stephanie? Yes. Why'd you go Z?
Because he gave us
Yes, it gave us a standard deviation, and it's the standard deviation of the population that we're using. Yes? Okay? So I don't have any room on this slide, but what would the null hypothesis be? Stephanie. Yeah, mu equals 128. Oh, this is running out of room. And the alternative? Jessica?
Mu is not equal.
Good. Jessica, why did you choose a two-sided alternative? That says 128. Why did you choose a two-sided alternative, Jessica?
Because it says different.
Yes, is different than the national mean. We're not trying to prove that they have high blood pressure. We're not trying to prove that they have low blood pressure. We're just trying to prove that they have different blood pressure. Yeah? Good? Okay. Job stress can severely affect the health of workers. A national survey of restaurant employees finds that 75% say that job stress affects their personal lives. One particular restaurant chain surveys a random sample of 100 of their employees and finds that 68 of them say yes. Is this significant evidence that the proportion of this chain's employees that suffer from job stress differs from the national proportion? Shh. Thank you. We're still thinking. Okay. Benin.
One proportion z-test?
Yes, this is a one proportion z-test. Benin, how did you decide on proportion?
Because it was 75%.
Okay, Benin saw 75%. I agree.
Plus. Where's the standard deviation of
If it's a proportions problem, you're not given a standard deviation. Remember, a standard deviation is like square root of p1 minus p over n, that kind of thing? Yeah. You're only given a standard deviation if you have a mean. Yeah? Okay. What? Yeah, George. There's no such thing as a one proportion t. That's the difference. Okay. How did you know? I have a question. How do we know that it is one proportion? I see two proportions. I see 75% and I see 68 out of 100. That's two proportions. It is, Grace.
Because the survey is only one sample. Like they only take one sample.
Yeah, what's this 75%? Francis?
Isn't that the population?
Yeah, it's like this is P and this is P hat.
Yeah.
Where is that 75% going to come out in my problem?
Nowhere.
False.
And P.
Oh, and
And, yeah, in the null and alternative hypotheses.
Sorry.
Yes? Okay. Why am I holding a pencil? I think this whole time I'm holding a pencil.
It would
Okay.
have been funny if you tried to write with the pencil. I would have done it.
Okay, so I know, Miguel. I know I don't have any space, but can somebody raise their hand and give me the null and alternative hypotheses? Miguel.
P is equal to 0.75, and then the I is P. Where does it go? Oh, it doesn't equal 0.75.
I agree.
That one.
Yes? Okay. So I want to test a claim about P,
the true proportion.
the true proportion of this chain's employees that suffer from job stress. And usually when you're trying to write your statement, you can like kind of copy off of the problem, right? That's usually a pretty good strategy. Okay, good. Remember your calculator. You go to one prop z-test, you have to enter in the null, and then it says x and n. What you'll enter is 68 and 100. Do you remember that?
Yep.
You enter it as like 68 and 100. You don't change it to a decimal. Do you know what I'm talking about? Make sure you know how to do these in the calculator. Okay. Next.
Of course.
High cholesterol has been associated with a higher risk of heart attacks. Does using cholesterol medication reduce the risk of a heart attack? The Helsinki Heart Study assigned middle-aged men at random to one of two treatments. 2,051 men took that drug, whatever it's called, to reduce their cholesterol levels, and 2,030 men were given a placebo. over the next 5 years, 56 men in the treatment group had heart attacks, and 84 in the placebo group had heart attacks. Is this significant evidence that the drug reduces heart attacks? Okay, think. And somebody say yes. Yep. Answer's yes.
And then that part.
You say this, but do you know how many I saw that said yes?
And then a draw.
Clearly the numbers changed. Okay. We're thinking now. We're thinking. It was a yes or no question. Okay. Do we have an answer? Okay, what test are we looking at? Michelle, see it. It is. You're right. Okay.
She said answer the question, not ask the question.
Guys. It is a 2 proportion z-test. Are there going to be any numbers in my hypotheses? There are not. Okay. So, can somebody tell me what my null is? Stephanie?
We want to compare.
Okay, so we want to test a claim comparing P. Let's give them some subscripts. P.
The G thing and the P for placebo.
Okay, so G for the drug and P for placebo. So comparing PG, the proportion of all men who would suffer heart attacks while on that drug, and P sub P, the proportion of all men who would suffer heart attacks while on the placebo. So Stephanie, what's the null? PG?
13.
It's okay. Somebody else want to?
Equals P.
Okay.
Is less than
Yeah.
so bad.
Okay. Are we really laughing at that? Okay.
This is on camera.
Okay.
Very inappropriate.
Glad my students are so mature. Okay. My lady, who actually works with small children on a regular basis. Okay. I'm just gonna, guys. Okay, it's getting too much. Are we okay with these hypotheses? Why did Stephanie choose less than? Cedric? Yes, if we're trying to prove that using this medication reduces the risk of heart attacks, which means the proportion of people on the drug who have a heart attack should be less than the proportion of people on a placebo. I hope that fewer people on the drug have a heart attack than people taking a sugar pill. Yes? Otherwise, it's not a very good drug. Francis?
Are all the tests in which we compare, let's say, 2 proportion or 2 samples, are the holes always going to be, for example, mu of this equals the mu of that?
Yes.
Or P of this equals P of
Yes.
that? Yes?
Everybody hear his question? That's a good question. He said, is everything where it's a 2 sample or a 2 proportion going to be like P equals P or mu equals mu with the subscripts in? Yes. And the alternative could be any of the 3. Megan?
Why is it a z-test instead of a t-test?
Because with proportions, it's always z.
Okay.
With proportions, it is always z. Yes? Okay. Good for the next example?
Yes.
Okay. A geneticist hypothesizes that half of a given population will have brown eyes, and the remaining half will be split evenly between blue-eyed and green-eyed people. In a random sample of 60 people from this population, the individuals are distributed as shown in the table below. Do the data support the geneticist hypothesis? Think.
I believe my habits.
Okay. Who thinks they know? Eliani. It is. Eliani says chi-square. Goodness of fit. Okay. first of all, I have a table with only whole numbers. So it could be chi-square. Doesn't mean that it is, but it could be. The labels for each of those are categorical, okay? So could I take the class and split them up into these categories? I could. Yes? All right. I only have one variable by which I break up my sample, eye color. So it's not homogeneity or independence. It's got to be goodness of fit if what I have is just a strip of data. Yes? Okay. We'll talk briefly about hypotheses. The hoe would be that the proportion of brown equals something. The proportion of green equals something. This is so bad. And the proportion of blue equals something. Given what is given in the in this statement, what is the proportion of brown supposed to be? No, not 30 over, where is it? Oh, yeah, I guess so. Yeah, 30 over 60, aka 0.5. I was like, come on, Nick, what are you doing? Yeah, but, well.
Yeah, he knows simple addition,
Who calls
miss.
1/2 30 out of 60? 60 out of 120. I mean, I know what you're doing,
Oh,
but
so fractions.
fractions are confusing to me, Nicole. I know, I'm sorry. Okay, so I think what Nick was saying, Nick was not only giving the hypotheses, but he was also kind of figuring out the expected counts. These add up to 60. Really fast, Nick.
60 people.
Oh, it does 60 people. And if half of them are supposed to have brown eyes, it should be 30. Yes? So Nick gave me both the null hypothesis and the expected count, but I wasn't quick enough to catch on to that. I've shared with you guys my worries about my intelligence diminishing right now. Yeah. It is a real thing. Well, it is kind of nice. It really is nice. I can eat whatever I want and I can be dumb. Okay. Nick, I apologize for targeting you. What should the proportion of green be, Stephanie? 0.25? Good. And then blue, Miguel?
The same.
The same. Can somebody tell me what the alternative would be here, Jessica?
One of these is not the same.
Yeah, and not one of them, at least two of them, because if one of them changes, they will no longer add up to 100%. So I specifically would have to say, at least two of these are incorrect. Good. Question,
Could you
Francis?
say that I don't know how to pronounce that. The hypothesis is incorrect?
No, I don't like that. I don't like it. Mathematically, if your null is, in terms of the percentages and stuff, I think your alternative should be more specific than just saying it's wrong. You know what I mean? Okay. Baby walkers.
Oh my god.
Are seats hanging from? Yeah, we did this question. Actually, we've done all of these questions.
Did you enjoy this?
Baby walker. Yeah, but you don't remember them all that specifically, so it was okay to reuse them. Baby walkers are seats hanging from frames that allow babies to sit upright with their legs dangling and feet touching the floor. Walkers have wheels on their legs that allow the infant to propel the walker around the house long before he or she can walk or even crawl. Typically, babies use walkers between the ages of 4 months and 11 months. Because most walkers have tray tables in front that block babies' views of their feet, child psychologists have begun to question whether walkers affect infants' cognitive development. One study compared mental skills of a random sample of those who used walkers with a random sample of those who never used walkers. Mental skill scores averaged 113 for the 54 babies who used walkers, standard deviation of 12, and 123 for the 55 babies who did not use walkers, standard deviation of 15. We're going to think. Yeah, you've done every one of these problems already. Okay. What test is this going to be, Jessica? I would say 2 sample T. It's a little bit ambiguous. You could have all, well, I don't know what I was about to write zest. 2 sample T zest.
You're hungry.
Because I was going to say you could have said a 2 sample Z test because I don't know if these standard deviations are for the sample or for the population. It just says standard deviation of 12, standard deviation of 15. Me personally, I would interpret it as the standard deviation of the sample, the way that it's written in the problem, which would mean a t-test. I really do think that is a slightly better answer. However, the ambiguity of it would allow for either t-test or z-test because it really doesn't specify, and that's not fair. Yes? T-sample t-test? What about my null hypothesis?
The mu with the walkers is equal to mu without the walkers.
Okay, make up whatever subscripts you want. Make sure you define them in your step 1. Sure. Did I actually ask a question?
Yeah, because it was, wasn't it?
Yeah.
There is no question. There wasn't a proof. I think the question said, is there evidence that the mental skill score is different? I know the problem is implying that the mental skill score would be lower for the babies who use walkers, but I think the actual question that followed just said is different. So we would do not equal to. But, I mean, you're right, I didn't ask the question. So, what my statement would say is I want to test a claim comparing, good, mu W, the average mental skill score of all babies who use walkers, and mu NW, the average mental skill score for all babies who do not use walkers. Null and alternative. 2 sample t-test, throw it in the calculator. Done. Yeah, exactly. Yes?
What's the difference between comparing? I mean, I know.
Say compare if it's a 2, say about if it's a 1.
What is the difference? Sometimes we use the difference. I want to compare.
About the difference, probably. You could actually probably go either way with that.
Let's keep
Yeah. Okay. But in general, a 2 sample or a 2 proportion test is always trying to see if there is a significant difference. Maybe it would be a difference specified in one direction, but it is always testing to see if there's a difference. Any questions? Okay. All right. The National Survey of Adolescent Health interviewed several thousand teens, grades 7 through 12. One question asked was, what do you think are the chances you will be married in the next 10 years? Is there a relationship between response and, that says sex?
I have a question.
I know. But other people might need a little bit more time to think, y'all.
Yes, I have a question.
Yeah.
How's the house going?
We'll talk later.
Right.
It looks like we are buying a house. Yeah.
What kind of house?
I don't. A single family home.
Good job.
Yeah. A farm. Nick.
I-squared for independence /
Okay, let's figure out which one it is. So, Nick. Right. Okay. First, Nick said chi-square test either for independence or homogeneity, and then when prompted, he specified the chi-square test for independence. Nick, first of all, how did you know that it was one of these 2?
because
He just knew.
Mylan's going like this. Jesus, what does that mean?
because of the 2.
Yeah. I've got data going this way. I've got data going this way. 2-way table. Which okay. Can somebody tell me why Nick sided with independence rather than homogeneity? Michelle?
It's because it's one big sample.
You stopped answering a question with a question? Yeah. It's because it is one big sample. Remember, independence is like America. One big sample that I then split up. If I took a sample of females and a separate sample of males, it would have been homogeneity.
China.
Yes? Stop it. It's going on the internet. Are we okay? Can somebody tell me what my null would be? No? Okay.
Your null?
No.
Yeah, Michelle?
There's no association between
Yeah, there is no association between survey answer and sex. Another way to say no association is to say that they're independent. This and that are independent. And then in the alternative say they are dependent or there is an association. Good. Okay. How does this always happen? Okay. Inference Toolbox. That's it in terms of recognizing the test. I think that was a good little exercise though, going through those. There was a time that we were really good at this. It's just, I feel like when we shove the chi-square and the inference for regression stuff in there, it makes you mess up all of the old stuff. But the old stuff is much more what's on the AP exam. The full Inference Toolbox question that's going to be on the AP exam is so much more likely to be a 2-sample t-test than it is to be anything chi-square or linear regression, okay? Those will be on the exam somewhere, but they won't be blah, big FRQ, little prompt at the top, big space for your answer, okay? Yeah? I could be wrong. I'm on camera saying this, but I could be wrong. Okay, Inference Toolbox consists of 4 steps. What are the 4 steps? Can somebody tell me the first step? Landra. Stating my hypotheses. If it's a confidence interval, all I need to do is state my parameter, okay? Instead of I want to test a claim, it's I want to estimate mu, the mean height of all Americans. Okay, Grace? Yep.
Okay, state the test and conditions.
Good, you remembered both. We need to name our procedure and we need to check conditions. Those get lumped in together. Jesus?
Calculations.
Do the calculations, the mechanics of the test. Who's doing the real work in step 3? Your calculator is. Good. And then step 4? Conclusions. For most tests, what are the 3 conditions? Francis? SIN, which stands for?
SRS.
SRS?
Independence.
Independence? Okay. Independence. Independence. That's 10n less than or equal to big N. Stop throwing this in for normality. That's wrong. 10n less than or equal to big N is independence. That's testing to see if my population is big enough to support me sampling without replacement. Yes? Do you remember a long, long time ago, I said if I take 10 cards out of a deck of cards and I don't replace them, is that independent? And you said no, because if you take the cards without replacement, it's not independent. And I said, yeah, okay. And then I said, what if I take 10 computer chips out of a shipment of 10,000 computer chips? Is that okay? And you said, yeah, that's probably okay. This is testing that. My population has to be at least 10 times larger than my sample size. That has nothing to do with normality. Yes? Cool. I'm going to talk about normality some more. We okay here? But we're not okay.
Yes.
Okay. You always do that, Stephanie. You're like, no, not yet. Now I'm okay. Yeah, it's not on there yet, but I'll add it. Yeah. For normality, if it is a means problem, I don't like how I did this. Okay. Ignore how the bullets come up. But if it is a means problem, there are 3 ways to verify normality. It depends on what you've got. What's one of them? CLT, which only applies if?
30 or more.
Yeah, if n is large. Let's just call it large. Okay, so CLT if n is large. Daniela? Yes, if you've got data, give me a graph, preferably a box plot, because it's easy to tell shape from a box plot. Jael?
Parent population.
Parent population is normal. Beautiful. So your 3 options are normal parent population, large sample size CLT, and got data, graph data. Give me a box plot and analyze it. This bullet should be a moved over bullet, okay? This is, the organization of this is misleading. You see? Make it one of those. A blob. Yes, my man. Okay. I want to stress this analyze piece, okay? Don't just throw a box plot on your paper and think that you've checked normality. say, yes, this box plot appears to be approximately normal. Or no, this box plot's kind of skewed right. I'm going to proceed with caution. Okay? You have to actually say something. Don't just sketch the box plot. Also, don't say, I made a box plot. It looks normal. I don't believe you. Okay? Sketch it. Yes? You don't need axes. It doesn't need to be pretty unless the box plot is the whole point of the question. Okay. That's for means. For proportions, are you allowed to talk about the CLT? No. Are you allowed to talk about the shape of the parent population? No. Don't do any of those things. If it's proportions. 17. Good. If it's proportions, NP greater than or equal to 10, and 1 minus P greater than or equal to 10. If it's two proportions,
You do it for both.
two of those. That's normality. Independence doesn't change depending on what kind of problem it is. Normality does.
Agreed.
Good? Give it a second. I'm thirsty. I'm going to take a little water break. Eventually.
Is that
I'm
water?
behind. I'm always behind. No.
Blame everything.
You can't blame everything on What just happened? Never mind. Okay. We're going to do an inference toolbox. Okay, we're going to do all 4 steps. Here's what we're going to do. We're going to do all 4 steps of an inference toolbox. Then we're going to take a break. Then we're going to come back and talk about type 1 and type 2 error. Then we're going to do multiple choice. Okay? What's wrong, Marcello? Type 1, type 2 error, or just messing with me? Okay. Have a calculator. At least one for every couple of people. I want everybody being able to see a calculator. Not a phone calculator, a real calculator.
Don't talk to Alice like that.
Why?
He doesn't deserve it.
What, Miguel?
Did you say something? No.
Wrong camera, guys.
Okay. We don't need to be noisy. Pat wants to compare the cost. Guys, thank you. The cost of 1 and 2 bedroom apartments in the area of her college campus. She collects data for a random sample of 10 advertisements of each type. Here are the rents for the 2 bedroom apartments in dollars per month. Here are the rents for the 1 bedroom apartments. Do 2 bedroom apartments rent for significantly more than 1 bedroom apartments? That's the question. Okay. Before, so what are we all doing in our calculators right now? Putting them in list 1 and list 2. Hey, I have a question. The sample sizes are equal, I believe. Do we have reason to believe that this is a paired test? It could be, since the sample sizes are equal. Yeah, but like,
No, because it's not the same.
yeah. What did they pair? Nothing. It's not paired. It's just 2 sample with 2 equal sample sizes.
So it's like 20 different.
Yes. Yes. If they did like, Michelle, if they did like 10, really? Good job. If they did like 10 buildings and compared a 1 bedroom and a 2 bedroom in each building or something like that, then we would think it would be paired. Actually, guys, listen up. Guys, Michelle and Marcello gave a really good kind of observation for why it's like this. They said it's 20 different apartments. They have nothing to do with each other. 10 of them are 1 bedroom, 10 of them are 2 bedroom. If it had been paired, then let's say they have like, they look at 10 different apartment complexes and they see how much a 1 bedroom costs in that complex and a 2 bedroom apartment costs in that complex. So I have 10 different complexes, a 1 bedroom and a 2 bedroom in each. Is there pairing there? There is. So that would be paired. This is not. Okay, keep clicking away at the data. Or do we have it already? Okay, we got it fast. List 1, list 2. Okay. Okay, raise your hand if you need more time for the data.
Yes, ma'am.
Oh, we're just high-fiving Marcello. Okay. That's nice. Okay. That's why I said raise your hand if you need more time.
I was cleared it.
I couldn't raise my hand. I was on the calculator. I know.
Sometimes I feel you force your laugh.
No, I know. I promise you. I think I just have a fake sounding laugh.
That's why I said
Somebody told me that I
it.
sounded really fake. And they were like, if I didn't know you, I'd think you were so fake. I was like, I mean, she didn't mean it in a mean way. It was like I just said something nice to somebody, and they were like, I would have thought that was fake if I didn't know you or something like that.
The smiles, the smiles.
Okay. Francis, are you good? Everybody else good? Okay. Okay. Kareem, could you not be asleep, please? Thank you. Okay. I want to. Oh dear, there's an arrow. Okay, that arrow's gonna stay there.
Okay.
I want to test A.
Okay, it's really.
Wait a second. What?
My wife.
What kind of test are we doing? I think it's a 2-sample t-test. Okay, so comparing.
Okay, that one.
mu1, what's mu? Can somebody raise their hand and tell me what I should write for mu1? Because this is starting to get ridiculous. Asahi? Yeah, but I can't just say 2-bedroom. Well, I guess I should start with mu2. Didn't the data start with mu2?
Wait, yeah.
Hang on. Sorry. It's too bad.
Yeah.
Finally, after like.
I know. I was trying to avoid it, but it's
necessary.
It is.
It's a game. Okay, maybe in
I know.
the margins.
No.
If half of it were outside the margin, it would be fine.
Okay. So. Oh, that's not good. So I did make it worse. Asahi said mu2 is 2-bedroom, but I need to say more than 2-bedroom, don't I? The mean. How about the true?
Oh my god.
Mean. Rent. Of all 2-bedroom apartments. So we're comparing mu2 and Stephanie said the true mean rent of all 1-bedroom apartments. Okay?
We're very long time. Okay, what does...
Good? Are we okay? Really?
Well, when is the other?
I get the sense that I'm losing you guys.
Just a little.
Can somebody raise their hand and tell me what the null hypothesis is? Francis?
mu1 equals mu2.
Okay.
mu2 or
Oh yeah, it was 2 first. That's a little confusing. What about the alternative?
Wait, what was the question?
Do you remember?
Is it me too greater?
F2 is
Yeah.
Greater than.
So whole is mu2 is greater than mu1.
Good? Okay. Step 2. What do I need to do first? Jael? Which is what?
2-sample T.
Guys, can we not be obnoxious, please?
2-sample T.
Thank you. Okay. And what else do I need to do in step 2? Check conditions. Cedric, what's the first condition? SRS. Do you remember if it was? Mark, can you hit the left arrow for us? Thanks.
A random sample of 10 acts.
Okay. Stated, yes. Something like that. Okay. Independence. Can somebody give me what they would say for independence for this problem? Grace, what would you say?
There are at least 100. 1 2-bedroom
Good. So they had a sample of 10 of each. So yes, there are at least 100, that's 10N, 1-bedroom apartments, and 100 2-bedroom apartments. Okay. Good? Normality, what do I need to do here? Benin? Box plot, how many? 2. So in your calculator, you need to make sure you know how to make a box plot of list 1 and then a box plot of list 2.
Oh my goodness. These calculators.
2 bedrooms.
I would like erase list 2 and then do list 1. Put everything out for list 1.
Somebody have a box plot for the 2-bedroom apartments. Just so I can look at it to sketch up here. Can I see it, Megan? Okay. That's not very pretty, is it?
No. It doesn't look very normal to me. Okay.
Is that about right, Megan? Yeah. Yes.
How is it possible for the men to be like the first quartile? Like, no one ever.
If my data set is 2, 5, 6, 7. Min is going to be the same as Q1. Oh, and then have to change. Yeah. Okay, does somebody have a box plot of the second set?
Oh! I was right in front of you.
I know.
What did you say?
What if we box them? What if we?
I don't know. Should I say louder? So then, are either of them approximately normal?
Approximately
The
not.
second one's a little bit better, but they're both pretty bad. Neither could be described as approximately normal. Proceed with caution. That's okay. Francis?
So you don't have to like technically write them underneath one another so that we could.
If they're both bad, I think you could just say that they're both bad. Michelle?
For every 2 sample proportion or of anything, we always look for independence of 2.
It depends. Michelle asked a good question. She said if it's a 2 sample or a 2 proportion, are you going to have 2 independent statements? There are at least 100 of these and at least 100 of these. I'd say it depends on how they're sampled. If they're taken as 2 separate samples, I would have 2 separate ones. If they were taken as one sample and then split up, I think you could do it as one big one. It just depends. Okay, step 3. What do I need to do? Calculator, what are the things I need to give for this type of test? T, degrees of freedom, p-value. What's T?
No.
Degrees of freedom?
17.89.
Yes. Yes. If it's, okay, with this it's neither. Stephanie asked a good question. She said with degrees of freedom, how do you know if it's n-1 or n-2? It's n-1 if it's a 1 sample t-test. It's n-2 if it's a linear regression t-test. If it's a 2 sample t-test, let the calculator figure it out for you. Okay. And then what's the p-value?
0.029.
0.029?
Kraemer, I thought I got the opposite. Maybe I put the.
You probably just put them in different order. It's okay. Well, did you get the same p-value? Or did you get a huge p-value?
The p-value was like I think it was huge. Yeah.
Then you put the wrong guy in your calculator. It should have been greater than, not less than. Okay. Can somebody give me a good first sentence for their conclusion? Jael?
With a p-value of 0.029. What's our alpha? 0.05?
Let's say 0.05.
Alright. Less than alpha equals 0.05. We reject. But no hypothesis.
Thank you for that. Okay. Stephanie?
There's enough evidence to conclude that
Yeah, that 2-bedroom apartments cost more than 1-bedroom apartments?
The right is higher.
No, wasn't it known that Me Too was greater than you?
The null is always a great equal.
Okay, my bad. That was an alternative. See?
Okay. This is perfect. Okay? With a p-value of 0.029, which is less than alpha equals 0.05, we reject the hoe. There is enough evidence to conclude that 2-bedroom apartments have higher rent than 1-bedroom apartments. Now, I meant to change the numbers so that we get a big p-value because we're fine at rejecting the null. We are not fine at failing to reject the null. You guys always write, I failed to reject the null, and then in context you accept the null, which is we know is bad, right? Just look at your shirts. Nick?
So like whenever we do this,
Yes.
instead of like referring the null hypothesis, we always refer to the alternative.
It's always in terms of the alternative, yes. If you reject the null, say that the alternative is true. Yes, accept the hop. Okay, it's weird to say that, but in context, yes. If you fail to reject the null, you don't have enough evidence to accept the hop. So that's what I would say. There is not enough evidence to conclude that 2-bedroom apartments have higher rent. That's what it would be if I failed to reject. Don't change the end of it, change the beginning of it. There is not enough evidence, rather than there is enough evidence. Good? Okay. 5-minute break? 5-minute break. Alright. I promise we'll finish on time. We just won't have a ton of time for multiple choice, which is a little bit of a shame because I did want to spend time on multiple choice because like I said, I think multiple choice is what's tricky here. But I'll give you the multiple choice, and if you want to do the multiple choice and then come talk to me about it, I think that's a great way to help bring your score up. Last thing I want to mention is type 1, type 2 error. What are you doing when you commit a type 1 error? Darius? Other way around. Yes. Well, and the only thing I a little bit take issue is when you said when you should have. It doesn't, I want to be clear here. Error is not like you messed up putting the numbers in the calculator, okay? It's sometimes our data is really unusual and it supports the alternative when really the null was true. Or our data supports the null when really the alternative is true. It's not us making a mistake. Do you understand that? We're dealing with probability here. Nothing's a guarantee. I never say I'm 100% sure that the null is true. Well, I never say that because that's accepting the null and we don't do that. But there's always kind of a threshold here, right? We're making a conclusion, but we're never more than a certain percentage confident. So type 1 error is rejecting the null when the null is actually true. So then type 2 error, failing to reject the null when the alternative is what's true. Yes? Good? Good, good, good? Okay. What is the probability of committing a type 1 error? Joe? It's alpha. It's whatever our alpha level is. Yes? So typically, with what we always pick, it's 5%. But, you know, if the problem says 1%, then it's 1%. 10%, 10%. What is the probability of committing a type 2 error called, Benin? Beta. It is called beta. And can somebody give me the relationship for how we typically find beta? Power equals 1 minus beta. That was a mess, but yes, beta. And we find that using power equals 1 minus beta. This is all you need for that. You'll either be given power and asked to find beta, or given beta and asked to find power. It's algebra, okay? Now they might not say the power is, they might kind of put it in context. Or they might say the probability of committing a type 2 error is 10%. What's the power of the test? 90%. Yes? Power is the probability of correctly citing with the alternative. Yeah? Fantastic. So for this particular alternative, you have a 95% chance, I guess, of citing with that alternative. So the probability of making a type 2 error would be 5%.
What can you do to lessen the probability of type 2?
Yeah, increase the sample size.
Look at that! You're psychic. Okay, so Michelle said, I've seen questions that say, what can you do to decrease the probability of type 2 error? And decreasing the probability of type 2 error is increasing the power, yes? So there are 4 things that we can do. Can somebody remind me of one of them? Miguel? Good, that's the first one I have. Increase the sample size. What else can we do? Francis?
Decrease the standard deviation.
We're going in order. We can somehow magically decrease the standard deviation of the population. I have no suggestions for you on how to actually do that, okay? This is not realistic. It's just sort of a mathematical relationship, okay? I'll be impressed if we pick the right next one. Dale?
I think it's like pick a number farther away from
What are the odds? Yes, choose a more extreme value of the alternative. So power and beta only makes sense if we're talking about our ability to detect a particular alternative. Now, our alternative hypothesis is always written as some kind of inequality. There are lots of values for the alternative. But I can only talk about power in type 2 if I'm kind of zeroing in on one particular alternative that I think is going to be true. By choosing a more extreme particular alternative, I increase the power of the test. It's easier to detect a more extreme alternative. That's the idea here. And then we're missing one, which is the one we most often do usually.
Increase alpha.
Increase alpha. Good. It increases the probability of type 1 error, but decreases the probability of type 2 error. Yes? Do you remember those problems where you have to describe which one's a type 1 error, what's a type 2 error, which one's more serious? Okay, which alpha level would you pick? If type 1 is serious, you pick the low alpha level. If type 2 is more serious, you pick the high alpha level. That's the idea here. Yes, Michelle?
How do you do like a more extreme alternative?
Well, I mean, you look at, say the ha is mu greater than 12. The particular alternative you're trying to detect is mu equals 14. More extreme would be anything more bigger than 12 than 14. I heard it, I know.
Always like the same number for like
yes, that's what I'm saying though, Michelle, is that we can only talk about power if we're talking about one particular alternative. So 14 is the alternative that I'm really trying to detect. If I need to increase power, I need to choose like 15 or 16. Yeah? This would make more sense if we actually went through the math of calculating power without being given beta, but it's such a mess that we're just not even going to do it, and it's okay because you don't have to do it on the AP exam, but that's the idea here. Okay. Yes? Good? Francis?
How likely is this to appear on the actual exam? Because I don't think I saw anything having to do with this on the faculty.
Type 1, type 2 error and stuff? Yeah, you did.
Where?
Multiple choice. Probably a couple multiple choice questions. Now last year guys, there was an FRQ on type 1, type 2 error. Okay? It absolutely happens. Okay, it had nothing to do with power and beta and all that stuff. The power beta stuff is very multiple choicey. Okay? However, type 1, type 2, that could happen on the free response. Now the fact that it happened last year on the free response makes me think that it's a little bit less likely to happen this year, but they don't go by that rule. Okay, they don't. And actually, I think a lot of people screwed up the type 1, type 2 error, and sometimes when a question is done poorly, they put it on the exam again because they're like, oh, teachers aren't teaching this well. Let's test it again. Let's test it again. Let's test it again. Yeah. Michelle?
So alpha equals 0.6, but that's
0.6? You mean 0.06?
I'm confused. Does the probability of type 1 and probability of type 2 equal 1?
No.
Okay.
Michelle said, does the probability of type 1 plus the probability of type 2 equal 1? No. But they do go in opposite directions. If one increases, the other decreases, but it's not necessarily linear like that. Yeah. Okay. Whoa. Stop. I'm just going to read to you. Many suppliers use inspection procedures for quality control. For example, a contract between a manufacturer and a consumer for light bulbs may specify that the mean lifetime of light bulbs must be at least 1,000 hours. As part of the quality assurance program, the manufacturer will institute an inspection program for each day's production of 10,000 units. An ordinary testing procedure is difficult since 1,000. Oh man.
It's Kraemer's room. Okay.
Okay. Miss Kraemer. Hey.
This thing is like 3 years old.
What's 3 years old?
I can't read it anymore.
At the flagpole? Okay, sure. Okay, bye. Where's that's all I got. Meet Dad at the flagpole when we're done. Okay. Okay. Sorry, I didn't want to call it on for everybody, but then I was like, I'm gonna forget if I don't. So, okay, sorry. Okay, an ordinary testing procedure is difficult since 1,000 hours is over 41 days. Do you understand this? They're trying to see if the light bulbs last long enough, but if you just test them to see if they last long enough, you have to run the test for 41 days to see if it burns out when it's supposed to, or if it doesn't last long enough. Do you see what I'm saying? So that's difficult. Since the lifetime of a bulb decreases as the voltage applied increases, a common procedure is to perform an accelerated lifetime test in which the bulbs are lit using 400 volts compared to the usual 110 volts. At such a voltage, a 1,000-hour bulb will last on average only 3 hours. So they crank up the voltage. The light bulb's not going to last as long. They can run the test shorter, but still, if it lasts too short, then it would have lasted too short over the long period of time. Yeah? Okay. This is a well-known procedure, and both sides have agreed that the results from the accelerated test will be a valid indicator of lifetime of the bulb. The manufacturer proposes the following procedure. The null hypothesis is the accelerated mean is equal to 3 hours. The alternative is that it's less than 3 hours. They sample 100 bulbs at random per day, and they reject all lots whose p-value is less than 0.05. 0.05 is alpha there. Yes? What would type 1 error be here? Can someone describe it? Michelle?
Minutes you got.
The accelerated doesn't equal 3 when it
Doesn't equal 3?
Does.
I mean, does equal 3.
No?
Does.
Is less than 3. Yeah?
I thought it was type 1 was rejecting the null.
It is. Rejecting the null means citing the alternative, but the alternative is one-sided, not two-sided. So start over and everybody listen to Michelle, please.
Okay, so when the mean accelerated is less than 3, when it really...
Okay, so we conclude that the average lifetime of this accelerated test is less than 3 hours, when really it's not. What happens? We throw away the light bulbs. Was that the right thing to do? No, the light bulbs were fine. So we throw away perfectly good light bulbs. Yes? Yes, it's very sad. Stephanie, you want to do type 2?
You distribute that light bulb, you say they're okay to sell.
Yes, we conclude that the light bulbs are okay. They do have an average lifetime of 3 hours, but really it's less than that. So we're distributing faulty light bulbs that are going to burn out too fast, and then people's lights will go off, and then they'll step on the cat, and the cat will get at them, and they'll have a bad day, right? Okay.
Sounds personal.
No, not me. Okay. We think type 2 is maybe more serious, depending on how much it's going to cost us to throw away these good light bulbs. So, if my options are alpha equals 0.01 and alpha equals 0.10, we decided type 2 is more serious. Which alpha level would I pick?
0.0.
The one with the numbers, the digits.
Wait.
Yeah, it was this one?
Yeah.
Because increasing alpha decreases the probability of type 2, which we decided was more serious. Yeah? Okay. I have one last little question. An appropriate night, and I actually hate this question, I think, and I'll tell you in a second why. Well, I was looking at it during your break, and I decided it's flawed. An appropriate 95% confidence interval for mu has been calculated to be 0.73 to 1.92 based on 15 observations from a population with a normal distribution. The hypotheses of interest are ho mu equals 0 versus ha, and I think that's supposed to be not equal to 0. Based on this confidence interval, we should reject the ho at the 5% level of significance. We should not reject the hoe at the, and I think there's supposed to be alphas there. I think the special characters just didn't copy over. We should not reject the hoe at the 5% level. We should reject the hoe at the 10% level. We should not reject the hoe at the 10% level. We cannot perform the required test since we do not know the value of the test statistic. Can we agree that E is wrong? I don't need the test statistic in order to draw a conclusion from a confidence interval. Yes? Yeah. Okay. So, what alpha level is my 95% confidence interval going to correspond to, Miguel? 0.05. So, can somebody tell me if I should reject or fail to reject and why? Francis?
Would you reject?
I would. Why?
Well, 0 is not within the confidence interval.
Yes. So I would reject the hoe at the 5% level of significance because 0 is not included in that interval. Why don't I like this question? Actually, maybe I do now because it just made it into a much more interesting question. Why don't I like this?
Because it has to do with type 1 and type 2.
No, that's not why. No, it has nothing to do with that. No, it looks statistics.
Because
Not reject.
that one.
Asahi, what do you think?
The population observation.
No, I'm okay with that actually. We have a smallish sample size, but I know that the population's normal, so it's going to be okay. Jessica?
Because it says not reject instead of fail to reject.
No.
Because this is what we should.
Just because you're good by yourself right now.
Because you're a Kraemer.
George, what do you think? No, should is okay.
Because it didn't have the not equal to before.
I think it's because there are 2 correct answer choices. What? Finish again.
Oh, I know what it means.
Why? Stop saying, oh, you don't know.
Unless we do know.
Oh, Michelle says, no, not D. Wait. See, why? Wait, I will be, you said D. No, but I will be extremely happy if everybody could be quiet and one person could raise their hand and tell me why C is also true. Nick?
Because if you're already rejecting it at the alpha level 0.05 or whatever, you'd also reject it at 0.10 because it would also be lower than that.
Yes. If I rejected alpha equals 0.05, that's because the p-value is less than 0.05. But if the p-value is less than 0.05, isn't it also less than 0.10?
Yeah.
Yes? So if I'm rejecting at the alpha equals 0.05 level, I'm also rejecting at the 0.10 level. Yes?
Yeah, that one.
Okay. Nice job. Thank you, Nick. Oh. Okay. It wouldn't happen on the AP exam. If it happened on one of my tests, sure. Okay, can we, I know we only have 10 minutes left. I'm not going to let you guys leave 10 minutes early. We're going to spend 10 minutes working. I'll give you the answers if you want so that you can check your answers later on or something. But can some people help me pass these out? I knew you would, Cedric. Thank you, buddy.
Cedric, you're a terrible person.
Oh, I can help.
Thank you, Francis.
Why not?
Help the pregnant lady.
I thought you didn't like this question because you were pregnant.
I'm going to stop the recording now.